Hi children, welcome to the Blast from Past, an exclusive question series from the JEE Advanced previous year questions. And here we have one chemistry question from JEE Advanced 2020 exam. JEE Advanced 2020 exam. Here we have one question, right? Let's go through. This is the question. Consider a reaction AB equilibrium reaction is given. AB equilibrium reaction at a temperature 1000 Kelvin at a time T dash. At a time T dash, the temperature of the system was increased to 2000 Kelvin. So at this time, temperature of the system increased to 2000 Kelvin, and the system was allowed to reach a different equilibrium. So this is the equilibrium at a lower temperature 1000 Kelvin, and this is the new equilibrium at a 2000 Kelvin. Hope you understand. At a T dash, temperature raised and is attaining a new equilibrium. So this is 1000 Kelvin equilibrium and this is 2000 Kelvin equilibrium. This is at a 1000 Kelvin. Hope you understand clearly. This is at a 2000 Kelvin, a new equilibrium. Throughout this experiment, partial pressure of A maintained at 1 bar. So whether the first equilibrium or second equilibrium, partial pressure of A maintained 1 bar. Given below the plot of partial pressure of B with the time. So this is partial pressure of B with the time. Now what we need to find out? The ratio of standard Gibbs energy for the reaction at 1000 Kelvin to that at 2000 Kelvin. So what intended to find out is delta G naught at 1000 Kelvin divided by delta G naught at 2000 Kelvin. This is what we need to find out. I don't have to tell you what is the relation for delta G naught. What is the relation? Delta G naught is equal to minus 2.303 RT log K, or here Kp, right? Fine. So what we get here? It will be minus 2.303 R, temperature becomes 1000 R into T log Kp1 or Kp at 1000 Kelvin divided by minus 2.303 R into temperature 2000 into log Kp2. So entire thing will get cancelled. You have 1000, 2000, log Kp1, Kp2. What is Kp1? What is Kp1? Kp1, it is B by A, or it is partial pressure of B by partial pressure of A. I don't have to tell you. It is available in the data from the graph. 10. For B it is 10 and A uniformly maintained 1 bar throughout. So it is 10 by 1. What about Kp2? What about Kp2? Temperature raised, and what is B? B is 100. So it is 100 divided by 1. So in both cases A remain constant 1. So in the first case B will be 10 and in the second case B will be 100. So when you substitute here, what do you get? 1000, 2000, so it is 1 by 2 on the top log 10, and here it is log 100. So it is 1 by 2, this is 1 and this is 2, you get 1 by 4, answer is 0.25. The final answer is 0.25 or 1:4. The ratio of standard Gibbs energy 1000 Kelvin, 2000 Kelvin. The final answer is 1:4, that is 0.25. That is the final answer. Right? It's a beautiful question connecting equilibrium versus thermodynamics. Right? With another chapter in the next one. Bye. See you. Take care.